So in this short video, I will demonstrate how to generate the tags, that is, or the target points that are necessary to generate the motions to do this pick and place operation. So actually, we don't need so many tags as one could imagine. There will be a logical flow, and we start with creating something to move this cube from this point up further to this point down in this pocket here, which is made. And then after that, in the following video session, I will demonstrate how to insert the action points and also to make the gripper motions, generate those, and also to get within the simulation the cubes to actually follow and attach to the gripper and released. And then in the final session, we will put it all together, so to say, and get all the 9 cubes to be moved from the original position to the next plate. So, okay, let's go. Let's get going with this now. So we make sure that we have the work object in the right table, because this is the right table seen from the robot's position. We have the tool here. We have move linear as a standard instruction set. That's fine. We can start with we can do this editing later on, but we get down with the set here. We set that as fine at the moment, and then we do some editing later on, so we don't bother about these things at the moment. So anyway, and we see here that we have all the cubes existing, or I can just click it. So the first one is this, which is just called cube, nothing else. Then we could rename those, but that's fine. So, and just to get some better overview of things in layout, I renamed the cubes. They were sort of disordered before, and different naming due to the copy-paste operations. So just a renaming thing, nothing else. But now I have cube 1 here, cube 2, cube 3, cube 4, 5, 6, 7, 8, 9. And this is probably the order that they will be manipulated from the positions here to their respective positions on the other plate as well. But it's just a renaming thing. So okay, if we concentrate on the first cube only that one, and the rest will be taken in another video session. So we start with defining a home position, and we do this right here because this is a home position of the robot, so to say. And we just click on, well, I can do like this now. We have the work object right table and the tool here, so that's fine. Yeah, by the way, we can see how that operates if we do this job orient, click on the tool, and then we can do this kind of manipulation. You see that we have a 2 center point, that's fine, and looks nice. And right click on that one, move to pose, jump home, and click on that again so we get out of the 2 center point. So what we do now is actually just to define this as a home position, so to say, teach target, click on that one, and if we open up path and targets, and work objects and the right table, and then we have target 1, which is just a home position. And then we move over above this plate somewhere in the middle, which, well, we'll see where we end up. So I do like this, so I click or highlight the robot, right click on that one, and mechanism joint jog, click on that one, and then we check, because now the 5th axis should be pointing downwards, and down goes that means 90 degrees. I just enter 90 on the keyboard and press enter, so I get that, and then we should swing the first axis in position, and that was the wrong one. So that means minus 90 degrees, like that, roughly. And this is pretty fine, but then we should be aware about that. Well, how are we going to pick those objects? Well, obviously we are going to do it by rotating the 6-axis 45 degrees. You will see that in a short minute. And that means that we do this right away in this kind of position, and then we will be in a good position then to do this kind of manipulation. And we can see that at this moment the yeah, well, we do like this, but that will be something like this, 135 degrees, like that. That's fine. And that means that we are in a pretty good situation now, that we have this, well, the x-axis of the table is in this kind of direction, and the y in that direction set pointing down. So this will be pretty fine, I think, in many respects. And we are well within the joint limits here as well. So this is a pretty good place to stand, and then we can retract the robot a little bit to be just over the middle of the robot, over the plates. So mechanism linear jog, that means we drive it a bit backwards, something like this, and we could drive it a little bit more over the first one. Choose to do so, because this will be in the main to pick from. Yeah, maybe we'll go down a little bit as well, something like this. So this could be a good point to go from the home position to this one and then further down. So we'll do teach target here. And now we have to define targets related to the cube. So there are many ways to do this actually, but I would like to refer the teaching process to the object we're going to manipulate. So I'm going to define a helping frame on the cube itself, and then we can relate the targets related to that one in a proper way. So in this way we define a frame here, and we can do it in different ways. We can create the frame from scratch, so to say, and position it somewhere and place it on the cube and rotate it and so forth. But we can also define the frame from 3 points in this case, because it's pretty straightforward. You can see how it works like. So create frame is the position of the frame, which is but just in the middle of the cube. And then we have the point on the x-axis and one on the xy plane, which, yeah, you will see how it works. So we keep that one and take that one, which is the mid or the endpoints of the cube, and click on that one again to highlight where we're going to define things. Start over again there, and then click on the mid, that is the position, and then it automatically goes to the next one, which is x-axis, which is that direction, which is the same as this direction here on the frame, on the teach target before, and the xy plane is anyway here, but essentially this one here, which is the y-axis in this case, and great. So that will be exactly the same orientation as this one here, the z-axis pointing down. And the next thing we can do is just take, for example, this target. We just, we can do whatever we like. A copy, for example, and Control V, get a new target here, and we can right click on that one, and then we can do a modify target, and then we can place it on a frame, and the frame should be, we have select frame here, it should be actually this one. So apply, and now that is the target, new one. And if we then go to select this one, right click and jump to target, so that works pretty fine this way. And what we can see here is that maybe we can go down. We are just at the 2 center point in this case. So what we need is now one target above the cube, which is sort of approach position, and one below this one. So if we remember that we are at this point now, and we can define this as the approach. So we modify the target, offset position, local, and we translate it in the Z direction up, which would be minus, say, 25 millimeter. See what happens. Close, and then we do a jump to target. That's pretty fine, I think. I mean, we can't be closer, but this is fine. That's perfectly fine. And then we take a new one. So Control C, Control V. This is that one, and we go down. I mean, there are many ways to do this, but this is just one of many ways. So modify target, and then offset position. Now we remember what we went up 25 millimeter. We have to go down a bit further, maybe 35 millimeter or even 40, but 35 should be pretty much okay, I think. Like that. And then see how far we went. Close. We can see, jump to target. Yeah. So, and now we remember that the distance between this plate and that plate is 300 millimeters. So that means that we should be able to actually copy those targets here and paste them and move them 300 millimeter Y direction. Correct. So we start to do that. Take one more time. Control C, Control V. Like that. So we got two new ones here. And those two we should actually move. And then we take modify target and offset position according to world coordinates, translation, which should be in the minus 300, like that one. Apply. So that should be pretty fine. It looks like. Good. And then we can make use of that one for actually making the motions. So we can rename them now in a proper way, so we know what we're looking at. So we call this just the home boss. And that one is above, evaporate. right table, and that one is approach. Approach cube, and this one is grip pose, and this one is detach approach, detach pose, and this one is detach push cube. For example, you can do it in a way actually. And when we've done that, we create a path. Pick and place cube, and we take it. Sorry, and we can have one create path in addition to that one, which is just initiate or whatever, which means that we move from the home pose to the above right table. That's fine. And in the pick and place, we go to the approach cube and grip pose, and then approach detach pose and detach pose cube. This one. And then to be sure that everything works, we do the auto configuration, check this one, click on that one, right click, make an auto configuration, and then we can see that, check that it is able to do the motions, move it on path. Should have been said that before, but in this case it's fairly straightforward. And right click on that one, move it on path. So now, of course, this doesn't work. You can see that because it's moving down, then intention is to grip it, move through the cubes here and then up. So we have to do some more things. So we do this approach cube through grip pose, and then we have to go up again, approach cube, like that. Go to up, and then we go to the approach detach cube position, which is here, move down, and then up again. So we have to do the approach detach after that one. Sorry, like that one. So this means that we have the approach cube, grip, approach, go to the detach position above that, and then detach and go up again. That should be the whole thing actually in this case. So we can check that, see how it moves. And then we can do like this. We can set the robot at target, see how it moves around this one. Approach. It went wrong here in the definition. I see that. Okay. So We have to redefine them, what we are doing here actually, because this is the detached position. Detached pose, and this is the approach. Just call this approach. That one. And what we're doing now is that we do like this, and take away that one, and we take this approach detach like that. So that should work fine. Then we check with move along the path. So that should work fine. And when we're done this, we just create the simple program out of this. So we have the initiate, the main, and the pick and place, the main, and then we can create another one, go home or something like that, or finish up. There might be more things to do in the end. That means that we go to the above right table and go home, something like that. And we do like this, that we stop view the robot at the target like that. Good. And after this, we just check that everything is working as it should in this simple program, and do a synchronization to Rapid. Create the program like this, and go to the Rapid tab, open up the Rapid, and check the main module. That's fine. Well, we miss actually one thing here. Strange. Did it first also. We need the finish up as well. So we just add that here. So remember that, and apply all, no errors, and synchronize to station as well, like that. Just do the simulation and see that everything works. One more time. Yeah, everything is working as it should. Okay, a few more small issues. We can, if we like to do that, add it in the initiate part. We don't need actually fine here. We can have a set 100, for example, and we can have set 100 here as well, and that could go for here. Set 100, that, and we see how it goes. It should be a smoother motion in general. Okay, then we continue in the next video session.